Hello again. To test the sets concept, I thought I'd try to solve a puzzle that appears in newspapers constantly, a puzzle called Sudoku. Now here's a copy of a sample Sudoku that appears in puzzles. I got it off the web. The object of this puzzle is that I have to put the digits 1 through 9 in each row, in each column, and in each 9-element block in such a way that there are no duplicates in any row, no duplicates in any column, and no duplicates in any block. And I have to use logic for that. Now, the reason this seemed to be a good sets problem, I don't know if I read this or if I came up with it myself, is that each of these boxes here is really the intersection of 3 sets. There's a set of the elements that are already in place on the row. Actually, I use the elements that are not in the row. So I do not have a 1, I do not have a 2, I do not have a 4, a 6, an 8, or a 9. The same thing is true for the columns. I don't have a 1 through 7, and I don't have a 9. And for the blocks, I don't have a 1, 2, 4, 5, and 7. So I figured the idea was to take these 3 sets of things I could put in here and see if there was one thing that was in the intersection of all 3 sets that I could put in. Well, that seemed reasonable, except I didn't reckon with how strange C++ is with its sets. It does not have, to my mind, a simple intersection method, but we'll see what's happening. Now the problem was how to put this in. So I came up with a way that might be quite frightening, I don't know, but it worked, at least so far. I got this one to work, I got the answer, so we'll see what happens. Now I'm going to move this over, try to get it out of the way, there it is. And now, here's the idea I'm playing with. I'm going to raise this up so I can make it a little bigger. And just take this for you. Just give me a second. There we are. And now I'm back. All right. My idea was that I was going to have 27 sets. Set 1 was the elements in 1, 2, 3, 4, 5, 6, 7, 8, 9. Not yet in that row. Sorry about that. Not yet in row 1. And then set 2 was the same for row 2. And so on. And that meant that set 10 was the elements not in column 1. And set 11 was the elements not in column 2, and so on. And then for the blocks, set 19 was the northwestern block. Set 20 was the north central block, and I'll move along a little. Set 22 was the western central block, and so on. Now that may be a little burdensome, but it seemed like a good idea if I could just make that work. Well, my problem was how to put in the information. For each element of the grid, the 27 items in the grid, I wanted to know which row it belonged to, which block it belonged to, and which column it belonged to. So I tried a rather strange method. I think you might think it's strange. I created three notepads, files. This pad is for columns. It says, if you're looking at the 9 by 9 elements that are in this grid, the first element I read in is going to belong to to set 10, because that's for column 1. The second element is going to belong to set 11, because that is column 2. Now, I didn't start with 0. That may have been a mistake, but I was stubborn and I didn't want to do it. So I had one for C, and then I had another one for rows. This one was pretty easy to set up. And then I had the one for blocks, which is here. This one was a little bit stranger, but it worked. It was basically the first 3 rows belong to blocks 19, 20, and 21, the next 3 to 22, 23, and 24, and so on. So I thought it was easier to read those in that way than to try to do some work to make them, to figure them out. I did try figuring them out at first. I found the program was a little bit messy, so I thought I'd go with this. Excuse me. Now I also had another file, and this other file was the Sudoku. So I had a file that was, I'll get it for you, the actual Sudoku puzzle. And I used 0 for any place where there was not already a number. So I actually have 4 input files for this particular program. Now let's take a look at how I did the program. I'll see if I can bring it up. First I'm going to close this, and now I'm going to bring up this, close it, and bring up Sudoku 2. So here's the program I played with. And you can see that didn't work. Let's try this. That's the class. I'll get back to that in a minute. There are my 4 files. And what do? I read in the elements from the 3 files telling me what row, column, and block that particular element belongs to. So the first element belongs to block 1, C1, and R1. And I kept doing that. And when I finished, I had the blocks, rows, and columns set up. Now I also wanted to make the grid, so I had to put in the elements for the grid also. So I had grid, but then I decided, for reasons I don't understand, that I wanted the grid to go from 0 to 8. So I had to play a little game there. You can see it. But if you'll notice, now that's the input. Now I have to create the sets. So what I did was I created a class called group. Group has a set, and I initialize the set to have all 9 elements in it. I have an erase, which just calls the set erase, an add, which calls the set insert, and a void, which uses the method I showed you in the last video to print out the elements of the array A, the set A. And this function is the intersection function, which I'll look at later. So I bring in the element, and anytime an element is in a row, a column, or a block, I erase it from that set. And now, so I can see if everything worked, I printed out the grid. Next, that was an output I don't need anymore. Now what I did was I'm going to run through this as many times as necessary. I'm going to have a Boolean variable called changes, which will tell me if I got any new items into the grid. So if changes is true, I found something new that I can put in the grid. What I do is I go through the grid element by element. If the item there doesn't have something in it, if the cell doesn't have anything in it, in other words, if it's 0, then I take the block, the column, and the row that it's in and intersect them. Then I look at that intersection. If the size of it is 1, then there's only one thing that can go into that place. I put it in that place, take it out of the 3 sets, and continue. And then when I finish, I print out the grid again. Now that changed the sets, so the next time I intersect, I might get answers differently in different places. So I kept doing that. The intersection, what I did, I have this problem when I create a group, it initializes the set to 1 through 9. So I had to erase them all. Then what I did was I used the iterators. You can see I have S1, S2, S3. I had them find the element. Now it turns out if they don't find the element, what they do is they bring back the in. So I have to test them for seeing if they are not the in. If they're the in, that means that element is not in that set. So if it's in all 3 sets, then I insert the answer in my answer A. Answer is going to be all the possibilities that could go into that particular square. And then I just return that. Then when I come back to the main line, if that's 1, good news. I can put it in. Now quickly, I'm running out of time again. I'll show you the results, and this file will go out so you can see it. That always happens. Let's see now. Alright. This was the original that went in. The first time I went through all 81 places, I actually made a few improvements. I thought I did anyway. Oh yes, this 5 is new, wasn't there before. There's a couple of new ones here. So some changed. In this next one you see more changed. Then it kept changing and changing. Then I had one where it was done, so there were no changes the next time, and I finished. And I think it's right. So Sudoku can be solved this way. However, I don't think that sets are a great, there's a great implementation of it inside C++. Now I'm going to close now.